Hey class, we missed you so much.
What's up?
We still miss you actually because you're not really here.
You guys are doing awesome. Keep it up.
Yeah, keep doing great. We know this is hard. You can call us every once in a while just to say hi. We wouldn't mind. Okay, so today's lesson is 8.4. It's called Similarity, Proving Triangles Similar. So the first way we're going to learn to prove that triangles are similar is by angle. Okay, so it's a double capital A, and in this lesson and the next two lessons we're only talking about triangles. That's it. Just triangles. Okay, so this is just from the book. It's talking about the angle similarity theorem. What this is saying is that if there are two angles in one triangle that are congruent with two angles in another triangle, then you can say that the two triangles are similar. So this sign, remember, is congruent. So if angle A is congruent to angle D, which it has right here, angle A congruent to angle D, and angle B is congruent to angle C, which we can see by the angle marks, then a triangle ABC is similar. So look at the difference. Congruent has an equal sign with a squiggly. Similar is just a squiggly. So triangle ABC is similar to triangle DEF.
What's really cool about similarity is the moment you hear the word similar, then you know that you've got two shapes that are going to be proportional. And once we have two shapes that are proportional, so I need you to remember these words. The word similar teaches us that we have proportions. The moment we hear that we have proportions, then we know we have a fraction equals a fraction. That will help us a little bit later, okay?
And the fraction equals a fraction is only with sides.
Yep, and this goes with the sides of the triangle. That's how you'll set them up and so forth. And we'll jump into that in a little bit, but it's important to kind of touch upon. This is why we do it. We have to know that two shapes are similar so that we can go find something about their sides later, okay? Well, I'm going to show you three pictures of how this works with angle. Okay? I'm going to teach you three ways that we can draw these pictures. The very first way is if I just have, first I better have my deal, A, B, C, and then I have another triangle, and I have D, or, yeah, let's actually use the right letters. D, E, F, and I have this marked. Let's say that was marked and this was marked. And I'm trying to do this so they're not just side by side. One picture's maybe turned. You can obviously see it's turned because this one's down here now. And then let's say that this was marked. And then this one was marked. Well, what do we have? We have one triangle with two markings. Two angles are marked, and they are congruent to the angles that are marked on another triangle. And obviously you can see they're different sizes. That means that these two triangles will be similar by angle. And then we can write a statement. Here's a statement, you guys. Triangle, and it never matters how you give your first three letters. Triangle, and we'll just go A, B, C is similar to triangle. Now watch how we have to follow the letters. A went with E. B had nothing, so it has to go with F. And C had two markings, so it has to go with D. And that would be one simple way to see two triangles side by side that are similar based on their markings of angle.
And notice that the second one is not alphabetical, which is okay because you match the angle.
Yeah, we had to match up the letters with the markings, not necessarily just in order of the letters. Okay? It never matters how you give the first three letters. It only matters how you give the next three letters. Okay? Okay, well that's one picture. Let me draw the next one. What if we had a picture that looked like this? Okay, and I have parallel markings here. You guys remember what parallel markings were? They're the arrows. Okay, now I'm going to put some letters on here. A, B, C, D, and E. Okay. Well, right now, there's nothing marked on the picture except for the two parallel markings. Now these two pictures are connected with a vertical angle. We've got to remember that when there's certain things on a picture, we can mark things. Like on my picture I went to a second ago that looked like this one, the picture that looked like this one that I drew a second ago. See, there's nothing I can personally mark on here. There's nothing I can mark. I can't mark anything on here because I don't know any other information than what they gave me here. And I don't know any other information than what they gave me here. And because the pictures aren't put together, like they're not touching, they're not related at all other than we have the markings that they gave us, I personally can't mark anything. But now I want you to look at my picture. I can personally mark some stuff on here because of previous information that we know. For instance, I know that these are vertical. Because they're vertical, I know they're the same, meaning congruent. I know that this line is parallel to this one, which means I know that this angle here has to be the same as this angle over here. We call those alternate interior angles from our picture. Do you guys remember this? Two parallel lines cut by a transversal. There's alternate interior angles right there. Those are the same ones I just marked over there, just a different picture, okay? That's kind of our remembering back from when we did that. Two parallel lines cut by a transversal. Two parallel lines cut by the transversal. Well, we have angle, angle here, and we have angle, angle here. That means the two triangles are going to be congruent. So let's write our statement. Triangle, let's go ABC again. Remember, it does not matter how I say the first three letters. I said them here. Now let's match them up correctly. A had nothing. So the only one that doesn't have anything is down here with E. B has 2 marks, so that goes with D. And C has 1 mark, and it went with C again. That's kind of unique because it was the vertical one. Okay? That's the second type of picture you're going to see and run into. Knowing now that those are similar. Now remember, what did I say when we think of similar? Proportional. Once we know that, then we can set up our fraction equals a fraction. We'll get into that later. Here's the last picture. You guys ready? I'll extend my page. Here's a picture that sometimes can be confusing to kids. You have to recognize, better draw a better line. You have to recognize.
That's almost as bad as me, Mr. Lee.
No, I'm the worst. Okay, A, B, C, D, and E. Okay, again, nothing else is marked on this picture besides the 2 parallel lines. You have to be able to see within this picture multiple triangles. There is the big triangle and there is the little triangle. Anytime I have triangles inside of triangles with a parallel line, I pull them apart. Okay, you ready? When I pull them apart, I do them like this. I draw one just the way it was. A, C, D, and then I draw the one that's smaller. A, B, E. Now, when I pull them apart, here's what I'm able to do. Watch. The angles that we pulled apart, angle A and angle A, are called reflexive because it's the exact same for both triangles. So we know those have to be congruent. We also know that these are parallel lines cut by the transversal, so we have corresponding angles. Notice I put 2 markings on there. So watch, angle C had 2 markings and angle B had 2 markings. Again, we have our simple picture of angle, angle. And all we'll do now is say a statement of triangle A, C, D is congruent to triangle. Notice it didn't matter how I said the first 3 letters. It only matters how I say the next 3.
Do you mean similar?
Similar, sorry. A and C had 2, so B and E. And then we have 2 triangles that are similar. Okay? Those are the 3 ways that you really need to be convinced and understand how the 2 triangles can be similar based on 3 different pictures. The first picture, the second picture, and our third picture is the one I pulled apart. That's triangles inside of triangles. Okay? We're going to do a little bit of a review with you on solving different information on pictures, okay?
Okay, so we're gonna practice what Mr. Lee just taught us. Okay, so our instructions for all of these is to find x. So number one, it says x is an angle, and it's this angle right here. Okay, so we're given the only angles that we know for sure are our right angles, which are 90, and our 34 degrees right here. So remember what Mr. Lee said. If you have two angles that meet and cross and make an intersection, you've got vertical angles. So we know the angle x right here is going to be congruent to this angle. And we don't know it yet, but we can figure it out because we have two angles in a triangle. We have 34 degrees and 90. And remember, all of the angles in a triangle add up to 180. So I'm gonna go 180 is equal to 34 plus 90 plus, I already have x on there, so I'm going to say y. 180 is equal to 124, and then I'm gonna plus y. I forgot this side of the board is crappy, so sad, minus 124. So y is 56 degrees, and that's my angle right here. So this is 56 degrees because 56 plus 90 plus 34 equals 180. So if this is 56 degrees, then x is also 56 degrees.
That's it.
Yeah.
Okay, I'm gonna work on number 2. This picture's a little bit different. Well, one thing that you guys need to look at and understand when you're looking at this one is, do we have similar triangles or do we have congruent triangles on this thing? And we're going to look at it and we're going to tell, all right, they are put together. If I pulled them apart, this side right here would be the exact same for both triangles. And then take a look. This side matches this side matches this side. We have congruent triangles. They're exactly the same because I could go 1, 2, 3 in the middle for both triangles. Well, the moment you have congruent triangles, you have congruent angles. So the angles are going to match up, which tells me then that this line right here bisects these angles. So this one right here and this one right here are 61 apiece. And if that one's 61, well, then this one's got to be 100 because those would have to match up. And so if I have 61 and 100 and x, now I can go find, because all three of these have to add up to 180. So we'll go x plus 61 plus 100 equals, not plus, 180, because that's what every awesome triangle adds up to. So x plus 161 equals 180. We will subtract the 161, and we will get x equals 19. And that's it.
I wonder if they can see the green. Can you see the green? I guess you can't tell us. I hope you can see the green. And just switch to black, yeah.
Or red,
Or,
whatever you
let's
want.
do red. Okay, so number 3, we've got another 2 triangles. We're still finding x. So this looks pretty similar to the last one because if you, like Mr. Lee said, we've got this side is congruent to that side, and then we have this side is congruent to this side because of the tick marks, and they share a side. Because they share a side, those are going to be exactly the same. So I'm going to go ahead and mark 3 lines there, which means their triangles are congruent, so everything is going to be the same. So what I know about, that means that these angles are also going to be the same, right? Because they're cut in half by this line. So this is 30 degrees. We've got a little angle mark. So this is also 30 degrees. And that makes it really nice because I've got this triangle right here is going to add up to 180. The angles will add up to 180, okay? So I've got 30 plus 28 plus x equals 180. 30 plus 28 is 58 plus x equals 180 minus 58 minus 58. X equals
122. 122.
122. Thank you. Yeah.
Perfect. Okay, that brings us to our last one. Now, this one is like one of the pictures I showed you. So, take a look at it. We've got parallel lines. And so, I know that I can and I have multiple pictures inside of my triangles, I'm going to pull them apart. I like to do that because, and I wouldn't have to, but I'm going to because I like to see both the pictures. So I just get good practice at it. I told you I like to draw one, that's X, that's 32. And then this one will be 58 because they are going to be congruent to each other. If I were to pick up this one and set it down there, because of the parallel marks, they're exactly the same. So then here's the big one, X, 58, and 32, because this one matches this one. So by angle, we've got similar triangles, but we also have congruent angles now between our 58 and our 32. So I'm going to say X plus 58 plus 32 equals 180. My writing's really sloppy. So X plus, what do we got, 90 equals 180. Is that right?
Yep.
Minus 90, and X equals 90
Nice.
on that one. And that's it. Okay? All right. We want to take turns on this one?
Yeah.
Okay. We're going to start out. We're going to find the indicated measures in this. Remember what this shape means. Parallelogram. Parallelogram of JKLM. Now, you're probably thinking, well, wait a minute. We've just been talking about triangles. So how's this going to relate? Well, look how many triangles are inside this shape. There's a lot of different triangles, you guys. There's like probably eight different triangles that we're looking at. Because there's this one, there's another one, there's two, there's three, there's four. Here's another one. There's another one that way. Then here's this one this way, and here's this one this way.
8.
There's at least 8 different triangles in that picture. Well, we need to make sure that we understand that we can find different information based on things being similar or congruent to each other from this picture. Okay? Well, we've got a parallelogram. That means opposite sides are parallel and congruent. Okay, so I'm going to start off with ML. Well, they want me to find ML. Well, I know that opposite sides are congruent, so that's 9. Not 90, just 9. Okay?
Okay, MJ, we've got another side. How do we know? Because it's 2 capital letters. So MJ's right here. I know the opposite sides are parallel and congruent. Mr. Lee already used 1 tick mark, so I'm going to use 2 tick marks. So if this is 7, MJ will also be 7.
Awesome. Okay, JN is what I want to find. I want to find J to N. Well, what is one of the rules on parallelograms? That the diagonals bisect each other. So we've already used 1 mark, then we used 2. So now watch, I'm going to use 3. 1, 2, 3. 1, 2, 3. So this must be 3.5, and this one must be 3.5. And we're good.
Okay, I'm going to sound like a broken record because, again, diagonals bisect each other. So if MN is 7.3, that's all we know about MK, right? MK is the long diagonal. We know 7.3, or we know MN is 7.3. I'm going to do 4 tick marks. 2, 3, 4. I'm going to do 4 tick marks here. And because this is 7.3, this is also 7.3, cuts it in half. But I don't want NK, I want the whole thing. So what am I going to have to do? I'm going to have to add 7.3 plus 7.3. 7.3 plus 7.3, which is 14.6.
Perfect. Okay, this one is dealing with an angle. I want you to remember the symbols. Measure of angle, MJK. The angle is actually at J, but then you follow the letters to see exactly how big it is. So MJK. So I'm going to try to mark it in right here like this, you guys. This is the angle I'm talking about. Well, on a parallelogram, opposite angles are congruent. So this one down here is 132, so mine up here is 132. I get all the easy ones.
Yeah, seriously, I'm stressed about this one. Okay. LMJ. Okay, so that is this angle. I'm going to do it in blue because I've got L, M to J. So do you see how that's the whole angle right there? Okay, so let's see what information I have. I've got, okay, I remembered. Okay, remember the things we know about parallelograms. Okay, we know opposite angles are congruent. We also know that consecutive angles add up to 180. So consecutive means next to. So if we look at our picture, we've got 132 is next to our angle LMJ. So 132 plus LMJ is going to give me 180, so that's way easy. So I'm going to cheat a little bit and not write a full equation because I know a lot of you think this way. 180 minus 132 will give me my answer, which is 48.
Yep.
Yes. 48 degrees for LMJ.
Okay, now we're gonna find the measure of MKL. So let's follow the letters, M, K to L, down here. This one's gonna be a little bit different because we know that, well, this isn't gonna be as easy as we think.
No, that's, you got it.
Because we've got 100 and we've got 48 right here total. Now we don't know that this line bisects this one completely. So we're gonna go MKL. So this is the angle we want right here. And the only way we're going to be able to find that is,
Yeah, how are you gonna find that?
because it doesn't cut it in half.
No.
I think they're assuming it cut it in half. You guys, I'm not 100% sure that this problem was set up correctly with the now had they said this was like a rhombus, then we would be able to instantly cut that 48 in half and we'd have that angle. I think that's what they're assuming we should do. But I'm telling you right now, we know it's not a rhombus because 9 opposite and then 7. All the sides on the outside are not congruent. Therefore, this line did not bisect and cut this angle up here in half.
So we can't, I don't think we
So
can.
I don't believe we can find the next two angles. Let's follow this one. Measure of angle LJM,
Yeah.
LJ to M, and they're trying to get us to find the exact same thing up in here. I am almost 100% sure we cannot do that,
Woohoo.
at least without one of these angles in the middle.
Yeah, we need to.
If we had one of the angles in the middle, then I believe we could do it because then we
Yeah.
can find this to this to this,
Yeah.
and we could start figuring some things out that way. But I'm saying these ones aren't able to be found
Yes.
because of what we have. So should have looked at that before. We'll have
Well,
to do that
Mr.
on
Lee's
the
so
next time.
smart, guys.
Yeah, right.
Nice.
Okay, I'll do this one with you. Determine whether the triangles are similar. So we're going to decide if these two triangles are similar. So look at the picture to start and say to yourself, is there anything I can personally mark? The pictures are separated. I'm not going to mark anything except for individual things on this triangle or individual things on this triangle. Now, what do I know about this triangle up here? I know that it gave me two angles. So can I find the third one? You bet. So I'm going to take 126, or I'm going to take 26 and 90, and I'm going to subtract those away from 180. So I'm just going to call this thing X. X plus 26 plus 90 equals 180. Add up the 126, that's going to be 116.